कैसे हो आप सभी लोग? आई थिंक सभी को मेरी आवाज आ रही होगी। ओके, आई होप सो आई विल बी ऑडिबल टू ऑल ऑफ यू। अगर कोई भी डाउट आता है तो आप हमें रीच आउट करिए। सो आज आपकी क्लास होगी, हम पैरामेट्रिक फॉर्म ऑफ डिफरेंशियबिलिटी पढ़ा रहे हैं, जिसमें मैंने कई प्रॉब्लम सॉल्व की थी, एक्सरसाइज 5.6 डील कर रहा था। तो एक बार सभी लोग जल्दी से क्लास ज्वाइन कर लीजिए और क्लास को शेयर कर दीजिए। और अभी जस्ट मैं आता हूँ 1 मिनट में पानी ले करके पीने के लिए, बिकॉज ओके, नो प्रॉब्लम। ओके, थोड़ा सा डेस्क मैंने सोचा, थोड़ा सा डेस्क मैंने इधर उधर कर लिया है, आपको थोड़ा नॉइज आया हो, नो प्रॉब्लम। ओके ओके, सो जल्दी से सभी लोग क्लास ज्वाइन कर लीजिए। ओके, सो ये आपको पढ़ाना है मुझे एनसीईआरटी मैथमेटिक्स क्लास 12। थोड़ा सा डेस्क घुमाना पड़ता है, देखना पड़ता है सब सही चल रहा है या नहीं। ठीक है, तो सभी लोग क्लास को ज्वाइन करिए जल्दी से। ओके, नाउ सो कल मैंने कहाँ तक प्रॉब्लम सॉल्व की थी आप लोग बताएंगे अपने, फिर मैं बताता हूँ क्या क्या प्रॉब्लम मुझे सॉल्व करनी है। सो प्रॉब्लम मुझे सॉल्व करनी है, आई थिंक वो थर्ड या फोर्थ प्रॉब्लम मैंने सॉल्व कर दिया था वहाँ पे। मैं देखता हूँ कहाँ तक प्रॉब्लम सॉल्व करनी है, उसके आगे प्रॉब्लम मैं सॉल्व कंटिन्यू करूँगा। और आज हो सकता है मैं काफ़ी प्रॉब्लम सॉल्व कर दूँ आपके लिए। सो क्लास को सभी लोग अच्छे से पढ़ रहे होंगे, और कोई डाउट आता तो आपसे पूछिएगा। 5.6, यस, मैंने जो प्रॉब्लम सॉल्व की थी वो सॉल्व की थी प्रॉब्लम नंबर 5 तक। ठीक है, प्रॉब्लम नंबर 5 तक मैंने प्रॉब्लम सॉल्व की थी। इसमें आई थिंक किसी को कोई डाउट नहीं होना चाहिए। ओके, अब थोड़ा हार्ड प्रॉब्लम आएगा, बट एक्सरसाइज मेरी आज फिनिश हो सकता है। सो देखते हैं ज्वाइन किया लोगों ने। प्रॉब्लम नंबर 6 से स्टार्ट करूंगा, 6, 7, 8, 9, 10, 11, 12, 11 तक प्रॉब्लम है, तो आज हम फिनिश कर देंगे इसको। ठीक है, आप सभी लोग ज्वाइन कर लीजिए जल्दी से, मैं इसको फिनिश कर दूंगा। प्रॉब्लम नंबर 6 से स्टार्ट करूंगा, 6, 7, 8, 9, 10, 11, 12, 11 तक प्रॉब्लम है, तो आज हम ओके, सो चलते हैं, प्रॉब्लम लिखते हैं, क्या प्रॉब्लम हमारी। राइट डाउन प्रॉब्लम नंबर 1, आपको सॉल्व करना है प्रॉब्लम नंबर 1 में। फर्स्ट प्रॉब्लम है फाइंड dy अपॉन dx, फाइंड dy अपॉन dx, फाइंड dy अपॉन dx if x is equal to, if x is equal to a times theta minus sin theta, comma y is equal to y a times 1 plus cos theta। ओके, ये आपकी प्रॉब्लम है, ये एक्सरसाइज एनसीईआरटी मैथमेटिक्स क्लास 12 की प्रॉब्लम है, और इसे आपको सॉल्व करना है, इसे आपको सॉल्व करना है। देखिए कैसे मैं इसे सॉल्व करता हूँ, आप लोग देखिएगा। और Write down solution. Write down solution. Okay. So find dy upon dx if x is equal to a times theta minus sin theta and y is equal to a times 1 plus cos theta. ये प्रॉब्लम ठीक है. So given आपको क्या है? Given that x equal to a times theta minus sin theta. Okay. And y is equal to a times 1 plus cos theta. Okay. So d is जो आपका x है वो थीटा का फंक्शन है, तो dx अपॉन डी थीटा इज इक्वल टू क्या होगा? ए कांस्टेंट एंड डेरिवेटिव ऑफ थीटा विद रिस्पेक्ट टू थीटा कितना हो जाएगा? 1 डेरिवेटिव ऑफ साइन थीटा दैट इज कॉस. ये क्या आ गया? dx अपॉन डी थीटा आ गया. फिर हम सिमिलरली dy अपॉन डी थीटा निकालेंगे. क्या? dy अपॉन डी थीटा. ठीक. सो ये आएगा a टाइम्स 1 derivative of 1 that is 0 and cos theta that is minus sin theta, that is minus sin theta. So this become minus a sin theta. dy upon d theta and dx upon it. You have to find the value of dy upon dx. dy upon dx. So this dy upon dx can be written as dy over d theta upon dx over d theta. Okay. So value of dy upon d theta is minus a times sin theta upon a times within bracket 1 minus cos theta. Now we have to simplify. Minus a. Now value of sin theta that is int. I am going to use 2 sin theta by 2 into cos theta. Okay. Upon a times. Now there are 4 formulae of cos theta. But I am going to use that one formula which cancels this one. So there is a formula 1 minus, this is plus, 1 minus 2 sin square theta by 2. So this 1 and plus 1 cancel. This plus a and a cancel. Okay. So you have dy upon dx. Dy upon dx is what? Is equal to minus 2 sin theta by 2 into cos theta. Minus 2 sin theta by 2 into cos theta by 2 upon, put the value of this 2 sin square theta by 2 sin square theta by 2. Okay. So this 2 and 2 cancel. 1 sin theta also cancel. Finally we have minus time cos theta by 2 upon sin theta. Okay. This now you know very well what this cos x upon sin x, that is cot x. So minus cot theta by 2. This is the answer. Okay. I think you understood the problem very well. Okay. Okay. Now let's see the another problem. Okay. Now problem number 2, that is exercise 5.1. Problem number will be I think 7. Now exercise आज की हमारी प्रॉब्लम नंबर 2. देखता हूँ एक्सरसाइज की कौन सी प्रॉब्लम है. एक्सरसाइज प्रॉब्लम है आपका 5.6 का Prime number has 7. Now find dy upon dx. Find dy upon dx if x is equal to sine cube t upon under root cos 2t. Okay. Now and y is equal to cos cube t upon under root cos 2t. And this is the problem, right? And you have to solve. Okay, now see. ये प्रॉब्लम है आपको फाइंड dy upon dx if you have been given the values of x and y. The values of x and y, you have to find the value of this. Okay. So find dy upon dx if x is equal to sine cube t upon under cos 2t and y is equal to cos cube t upon under cos 2t. Okay. Find dy upon dx. No. Okay, no problem. No problem. Okay. Write down solution. Write down solution. Okay. We have x is equal to sine cube upon under root cos 2t upon under root cos 2t. Okay. If x equal to sine cube t upon under root cos 2t. If x equal to this, find dy upon dx, right? So now differentiate here this equal to we have dx upon dt. Dx upon dt is equal to first derivative of sine cube t. No, yes, under root cos 2t. I think you know the formula. Which formula you know? And derivative ddx of u upon v. That is the quotient formula. V du over dx minus u dv over dx upon v square. On v square. So this is d under cos 2t. Okay. Derivative of sine cube t. This becomes 3 sine square t. And derivative of sine t, that is cos t. Minus now u means sine cube t. Now derivative of 1 this. So we have 1 upon 2 under root n x to the power n minus 1. So you have cos 2t power n minus 1 v minus 1 by. Okay. Now derivative of cos 2t is minus sine 2t and derivative of 2t, that is 2. So this 2 and 2 cancel out upon v square means cos t square. Right? Now, so you can simplify this problem like that. Dx upon dt is equal to you have 3 under root cos 2t. 3 under cos 2t sine square t into cos t. And this minus plus and sin 2t का sin cube t under root we have cos 2t whole power minus 1 upon v square means cos t. This is the value of dx upon dt. Okay, no problem. Yes, no problem. Now we have here y is equal to, can see, cos cube t upon under root cos 2t. तो इसको सॉल्व करना है u अपॉन v से. कैसे सॉल्व करना है? u अपॉन v से फिर से सॉल्व करना है. वो कैसे सॉल्व करेंगे हम यहाँ पे? dy अपॉन dt is equal to under root cos 2t. Okay, derivative of cos t means 3 cos square t. Derivative of cos t, that is minus sin t. Okay, and minus derivative of cos under root cos 2t, 1 upon 2 power cos 2t power n minus 1 means minus 1 by 2. Derivative of cos 2t means sin 2t, that is minus sin 2t. Derivative of 2t means 2 upon v square means cos 2t. Okay, so dy upon dt you can simplify. We have 3 under root cos 2t cos square t into minus sin t. This minus and plus, this minus and this minus, plus 2 and 2 are cancelled. You have cos 2t power minus 1 by 2. And one more factor, I just forgot to multiply this factor, cos cube t. Cos cube t multiplication. So you have sin 2t into cos cube t upon v square means cos 2t. So now we have value of dx upon dt and dy upon dt, right? So now dy upon dx will be what? Dy upon dx can be written as dy upon dt upon dx upon dt. So you have to put the value of this both dy upon dt and dx upon dt. Okay. Now I am going to put these values in the next page. Just follow me. Okay. So yeah. So we have dy upon dx is equal. Now put the value of dy upon dt. So dy upon dt is this value, 3 under root cos t, 3 under root cos 2t. Okay. Next, cos square t into minus sin t. Cos square t into minus sin t plus cos 2t plus cos 2t and whole power minus 1 upon 2 and sin 2t into cos cube t upon cos 2t upon, put the value of dx upon dt, that is we have 3 under root cos 2t, 3 under root cos 2t into, we have sin square t cos 2t, cos t, sin square t into cos t plus sin 2t cos sin cube t, sin 2t sin cube t into cos 2t power minus 1 by 2 upon cos 2t. So now you can say this cos 2t and this cos 2t are cancelled out. No. What we can take common? This is you have to take. Okay. Yes, we can take common. Okay. Otherwise, I have to finish here. No problem here. So dy upon dx. I'm taking some few terms common. That is, we can take common where r cos square t. Okay. Now cos square t. You can take common here sin t. Okay. Now see. So we have minus 3 under cos 2t plus cos 2t whole power minus 1 by 2. Now cos this becomes cos t. Next sin 2t is equal to 2 sin 2 cos t. Sin t we already count, so we have 2 cos t. This becomes cos square t, and also we have 2 cos square. Finish. Upon take again common. We are taking common sin square t cos t. Sin square t and cos t. Common, right? So we have what? 3 under root cos 2t. Okay? And plus we have taken common what? Sin square t. So sin and plus 2. And also we take cos t. 2 sin square t cos 2t whole power minus 1 by 2. Now sin t upon cos t, that is tan t. Cos square t upon sin that is cot square t. You can take. Also you can simplify more. How? One cos is going cancel out here, sin here. Finally you have cos t upon sin t, that is called cot t. This is called cot t. And within bracket you can write minus 3 under root cos 2t plus cos 2t whole power minus 1 by 2. I am writing here. This is cos square t. Upon आप न्यूट्रल में ले सकते हैं 3 अंडर रूट cos 2t plus 2 sin square t and 2 cos 2t whole power minus 1 by 2. So lengthy and complicated. Not complicated but lengthy. There is no calculation. There is so much calculation. But still, I'll solve a problem to all of you. Because some of you go through the solution, so you can just solution I just solved for you. Okay, now next problem. वही प्रॉब्लम क्लास आज की क्लास की प्रॉब्लम में होते हैं थर्ड. देखिए थर्ड प्रॉब्लम हमारी क्या होगी. नाउ वी हैव हियर फाइंड dy upon dx. Find dy upon dx if x is equal to within bracket a within bracket cos t log tan t by 2 cos t plus log tan t by 2. Okay, and y is equal to we have a sin t, y is equal to y sin. So this is the solution, this is the problem. Now you have to solve this. Okay, now see. So find dy upon dx if x equal to a times cos t plus log tan t by 2, y is equal to a sin t. Okay. So now you have been given what? X is equal to a times, then make it cos t plus log tan t by 2. Okay. Now find dy upon dx. Sorry, dx upon dt. So dx upon dt is equal to what? ये हमारा क्या है? कांस्टेंट रख दिया. डेरिवेटिव ऑफ cos t is minus sin t plus derivative of log x, that is 1 upon x. So 1 upon tan t by 2. Okay, next. Derivative of tan x, that is sec square t by 2. Derivative of t by 2, that is 1 upon 2. I think no problem? Yeah, no problem. So dx upon dt, put here value t by 2 and 1 by 2 take common, and 10 by 2, 10 t by 2 sec square t by 2, sec square t. Okay, so you can convert in case of sin and cos. Simply this is what I'm not going to convert. Yeah, you can convert 1 by 2 sec tan t by 2 is this converted as what? Yeah, wait. Cos t by 2 upon sin t by 2 and 1 upon cos square t by 2. This is, so 1 upon cos t, 1 cos t cancel by 2. We have a minus sin t plus, now you have 2 sin t by 2 into cos t by 2. This is the formula of sin t. Yes, 1 upon, this is value of sin t. Okay, this is value of 1 upon sin t. Value sin t is equal to 2 sin t by 2 into cos t. That's all. So now find dy upon dx. So d upon dt. So we have y is equal to a times sin t. So dy upon dt is equal to a cos t. A cos t. Okay. Now you have to find dy upon dx. So this dy upon dx can be written as how? Dy upon dt upon dx upon dt. So put the value of dy upon dt, that is we have a cos t. Now you can see this is the value of dy upon dt. Now upon dx upon dt. So dx upon dt is equal to a times within bracket minus sin t plus 1 upon sin t, that is cosec t. This a and a cancel out. You have dy upon dx is equal to cos t upon minus sin t plus cosec. Now this is the value of dy upon dx. We solve the problem. Problem is simple, that's why it's solved very well. I know this problem is taking only 2 minutes. The last problem you can imagine. The problem was took 5 minutes or 6 minutes. Depends on the problem, right? Should now move to the next problem, problem number 4. Now we have y is equal to find dy upon dx. Find dy upon dx if you have x is equal to a sec theta and y is equal to b tan theta. Okay. So for add-on solution, Okay, no problem. Okay. Sure. Okay. So find dy upon dx if x equal to a sec theta and y is equal to b tan theta. Okay. Yes. So now, given that x is equal to a times sec theta. Okay. So dx upon d theta is equal to what we have? Derivative of sec x into tan x. So this becomes a sec theta into tan theta. Now y is equal to d tan theta. Okay, so dy upon d theta. So b sec square theta. Okay, now dy upon dx, this will be written as dy upon d theta upon dx upon d theta. So the value of dy upon d theta will be sec square theta upon value of this dx upon theta, that is a sec theta into tan theta. This one sec and sec cancel. You have b upon a into sec theta upon tan theta. Okay. Also, this can be simplified more, and this can be written as b upon a. Okay. Sec theta is equal to 1 upon cos theta. Okay. 1 upon tan theta written as sin theta upon cos theta. 1 cos theta goes to numerator. So this cos theta and this cos cancel. We have b upon a. 1 upon sin theta is cos theta. So this problem is solved. Okay. Now let me tell you more about this problem. Now you have the equation of hyperbola, that is x square upon a square minus y square upon b square equal to 1. Right? So these are the equation, that is x equal to a sec theta, y is equal to b tan theta. These are the parametric equations. These are the parametric equation of hyperbola. Let me tell you how. Write down LHS. We have LHS is x square upon a square minus y square upon b square. So this can x is equal to what? A sec theta square upon a square minus b tan theta, b square tan square theta upon b square. Right? So this cancel out, and you know very well This is going to be a square upon a square. Cancel out. This is cancel out. You have sec square theta minus tan square. Now this is an INT and this is sec square theta minus tan square theta is equal to 1. And this is equal to RHS. Okay, so these x equal to a sec theta, y is equal to b theta, these are the nothing. These are the parametric equations of a hyperbola. Of a hyperbola. I think you got the point. No problem. Okay. Now move to the next one. This is problem number 5. So we have problem number 5. Okay. Now we have exercise problem number 10. Problem number 10, that is find dy upon dx. Find dy upon dx if we have x is equal to a cos theta, a within bracket, cos theta plus theta into sin theta, and y is equal to a sin theta minus a sin theta minus a sin theta minus theta cos theta. Okay, so write down solution. And this is the second last problem of the exercise 5.6. The second last problem of exercise 5.6. Okay, now. So for today I will finish this equation. Sorry, exercise 5.7, 5.6. I will continue with exercise 5.7 from tomorrow. Right? So find dy upon dx if x and y are given in terms of theta. Right? Parametric form. So we have x equal to a times cos theta plus theta into sin theta into sin theta. Okay, so dx upon d theta. So a, now derivative of cos theta, that is minus sin theta, plus derivative of theta and sin theta. We are going to use here product rule. So derivative of theta, that is 1 into sin theta plus theta into derivative of sin theta, that is cos theta. Okay, okay. So this can be simplified as dx upon d theta is equal to a times, now minus sin theta plus sin theta plus theta into cos theta. Yeah. So this plus and minus sin theta are cancel out. You have a times theta into cos. This is the value of dx upon d theta. I think okay. So we have dx upon d theta is equal to A times A theta into cos theta. Now we have y is equal to what happened? Not working? Okay. I think they are stuck down. But no form is working. Stuck down. First time I'm watching this. What is this? Yeah, no. Clear. Okay. Okay. Very good. So now we have y is equal to A times sin theta minus theta cos. Sin theta minus theta cos theta. And you have to find here dy upon d theta. So dy upon d theta is A. Now derivative of sin theta, that is cos theta, minus derivative of theta into cos theta, theta derivative, that is 1 into cos theta. Next, and derivative of, you see, plus theta, derivative of cos theta is minus sin theta. Minus sin theta. Now, so dy upon d theta is equal to, you have cos theta minus cos theta and plus theta into sin theta. So this cos theta and minus sin theta cancel out. You have dy upon d theta, dy upon d theta is equal to A theta into sin. So dy upon dx is equal to dy upon d theta upon dx upon dt. dy upon d theta is A theta into sin theta upon, this is dx upon theta is A theta cos theta. A theta cos theta. So A theta and A theta cancel out. Sin theta upon cos, that is tan theta. That is tan theta. Now this is the value of dy upon dx. And this is the second last problem of exercise 5.6. Okay. Now the last problem of this exercise, that is 5.6. To make solve it for all of you. This problem number 7. Now, I think error is gone. Network is seen. Yeah, we have find dy upon dx, find dy upon dx if you have x is equal to a under root 8 power sine inverse t. Okay, comma y is equal to under root 8 power cos inverse t. Okay, yeah. This is the problem. And so that dy upon dx is equal to minus y upon x. Minus y upon x. This is the problem. Okay? Now, how we have to solve it? Write down solution. Write down solution. Okay, this is the last problem exercise. So we have x is equal to, now see, x is equal to under root e to power sine inverse t. Okay. Okay. Now we have power equal. So dx upon dt what? Listen carefully. Okay. So dx upon dx upon dt power got it, and c power n minus a sine inverse t whole power minus 1 by 2. Now derivative of a is a to power x, that is a power x log a. So a to power sine inverse t and log a. And next derivative of sine inverse t is 1 upon under root 1 minus t. This is the value of what? Dx upon dt. Now similarly we have dy upon dt. dy upon dt is 1 upon 2 a to power a cos t, a cos inverse t power minus 1 by 2 and a to power cos inverse t and log a, and value of this cos inverse t is minus 1 upon under root 1 minus t square. Now you can divide, you can write here dy upon dx is equal to dy upon dt, okay, upon dx upon dt. This is well. So put the value of here dy upon dt. So we have 1 upon 2 a cos inverse t whole power minus 1 by 2. Okay. Okay. And a cos inverse t log a cos inverse t log a, and derivative of this 1 upon under root 1 minus t square. This is a derivative of cos inverse t. Similarly, dx upon dt 1 upon 2 here dx upon dt 1 upon 2 a sine inverse t whole power minus 1 by 2 a sine inverse t and sorry e to power sine inverse t e to power e to power sine inverse t and this is log of what? Log of log a log a and derivative of sine inverse t 1 upon under root 1 minus t. Now the terms what I cancel 1 upon 2 cancel 1 upon 2 cancel and a sorry not cancel. Okay, log a cancel. Okay, e to power, just see here, e to power minus 1 by 2, right? So we have dy upon dx is equal to, just see, we have E cos inverse t whole power minus 1 by 2 upon E sin inverse t whole power minus 1 by 2. Okay. Now into E, this is also 1 upon 1 t, so cancel, only minus will come out. Minus will come out. So this is also cancelled, minus will come out. A cos inverse t upon E sin inverse t. Now you have to show the value of this is what? Y upon x. Okay. Find the value of y upon x. Y upon x. This is the value of, okay. You can simplify more. Okay. Now this is what? Dy upon dx minus. This is e to power cos inverse t power minus 1 2. This is plus. So you have a to the power cos inverse t. And this will come in under root, okay, upon under root e power sin inverse t minus, and a under root a cos inverse t is what we have? We have y. So this is y upon x. Hence proved. Hence proved. So now exercise 5.7 is closed. Exercise 5.7 is closed. We will continue with the next lecture. That's will continue with the next exercise also. Exercise that is 5.7. Okay. So thank you all of you. God bless you all. Have a good night. Miलते हैं कल क्लास.